hot and cold flasks. In this density lab, we are going to heat one Erlenmeyer flask, 250 milliliters of water, to about 200 degrees Fahrenheit. That flask is currently sitting right now on a hot plate, which is heating the water. There's also another flask involved in this demonstration, and it is a flask filled with 250 milliliters of cold water. One is approximately 200 degrees Fahrenheit, the other is approximately 55 degrees Fahrenheit. In a few minutes, we're going to add food coloring to the hot water flask, just so that you can see the hot water versus the cold water. So we're going to add blue food coloring to the hot water flask. And I'm actually going to go ahead and take it off of the hot plate. You can see here, judging by the two flasks, that the hot water molecules are moving very quickly, and that the food dye actually moved and dispersed very quickly through the flask as well. What I'm going to do in just a few minutes is very carefully lift the hot water flask up and over the top of the cold water flask by placing a plate between the two of them. Once I slide that plate out, there will be nothing between the two flasks, and we'll see what happens to the water. You can make a prediction at your seat now as to what you think will actually happen when I do that. I'm just going to top off the top of these so there's no air involved in our demo, and hopefully I'll be able to do this with a smooth transition. This is hot, so here we go. Very hot. I'm actually going to use this rag to help me slide that out from underneath it. Okay, hopefully, even though this is on a camera, you can see that the hot water, blue hot water, is staying completely up top, and the cold, clear water is at the bottom. And at this time, they are not moving. You need to use density to explain why. Here's a closer look at where the flasks meet, so that you can see there is, at this time, no mixing between the flasks.